All right. Yeah, luckily I'm back. My computer's back on. Right. So where were we? Okay, so we are updating 11. Okay, these two neighbors of vertex, I forgot what the vertex numbers are, but from this vertex until here, we're all good, right? And we'll just update them there. And I guess we are now towards the end. Let's see. So we have here 10, or we're done with the 10, with the 11s, right? So here we have 11, and then going through this vertex will cost us 13, but we already have a smaller label, which is 9 before. So that's good. We'll just keep the 9 intact over there, okay? And the last thing is here. So we have 12, then going from 12, going through this edge will give us a value of 15, which is smaller than the original value 19 before. So that will be relabeled as a 15. Okay. And I think we are all done here. Okay. Because all of the edges are traversed. So that means we can now complete the distance, the column of the distance matrix corresponding to vertex V1. Okay. Now, hold on. I'm hearing some echo, but okay. I hope the echo is gone now. Yeah. So that means if you want to find the shortest path starting from V1 until V8, for instance, you need to look for, we know the distance right away. The distance from V1 to V8 is 15 units. So if you want to know to get the shortest path, you need to look at all the possible paths and then count how do you get 15 out of this, right? So probably let me see if I can reconstruct that. Yeah. So that's going from here, then there, then that's the shortest path from V1 to V8. There are other paths, but that's guaranteed to be the shortest one. Okay. And the nice thing about this is we can construct the column of the distance matrix from V1 to V8. From V1 to all of the other vertices. So let me relabel them again so I can illustrate how this is done. So this is V2, this is V3, this is V9, this is V6, this is V4, V5, V7, and V8. Right. So if you are constructing the distance matrix, maybe where can I write? So I'll probably write here. So V1, then here you have V1, V2, V3, V4, V5, V6, V7, and then V8. You'll just need to put all the labels on the vertices themselves, right? So here V1 to V1 0 because the label at V1 is 0. V1 to V2, the shortest path is of length 4. So you put a 4 there. Then V3, the value is 5, so put a 5 there. That means it will only cost you 5 units to get from V1 to V3. And then for V4, where's V4? The value is 9, so you put a 9 over here. Then V5, that's a 10. V6, that's an 11. V7, where's V7? Over here. There's going to be a 12. And V8 will be a 15. So that's the first column of our distance matrix. Now, if you want to construct the entire distance matrix using Jigsaw's algorithm, then you need to redo all the computations, but now starting at V2. And then again, redo the algorithm starting from V3. So you just choose another starting point, run Jigsaw's algorithm again, and then you'll have different labels, and those labels will become the columns of your distance matrix. All right? All good? Any questions? Okay, I think everything's fine. Let me see. Okay, there are some other things in the slides, but I think I will skip them. Though the slides are very detailed, so you can go through them. There's still a lot of things. Probably we'll rediscuss clustering again when we look at clustering machine learning algorithms in the coming days. So I won't discuss them right now. Anyway, we only have 7 minutes more. Let me just go through the rest of the slides and see if there is something important over here. Okay, so here's just some examples of networks that can be analyzed using machine learning tools or data science tools that requires graph theory. This is a bipartite network of what? Probably these are some diseases and the genes or the genomes that are cause them or are associated with them. I'm not familiar with these relationships, but maybe you can explore this later. And what else? A human disease network. So here are some other examples over here. I'm not sure what the connections between these guys are, right? But yeah. So here are some multipartite graphs, but I don't think you need to know them in details. These are more of graph theory things, but we're just equipping you with the basics. So I guess we're good. Random networks. Oh, random networks in data science are also one of the famous things right now. They are sort of a trend. So you can explore data science later if you want. I think this is from the book of Barabasi, Network Science. There's a nice discussion of graph theory related things in networks, in real world networks, which can be analyzed using different tools from data science. Right? So, but in essence, in the two sessions that we had on graph theory, we just look at the basic graph parameters, some definitions, and some things that we can take a look at, and some things that you might need whenever running classification or clustering algorithms. Okay, I think I'll stop here. Do you guys have any further questions or comments?
Good question, sir.
Go ahead.
No, I don't have a question. It's okay. My dad was clear.
All right. Yeah. Okay. So just to recap our schedule. So next week, on Thursday, we'll start actual machine learning algorithms. Just I think that's a nice way to cap the course. And the project that I will give you, or the final problem set, will be for you to collect actual data and use some clustering and classification algorithms on them. All right. So I'll teach you how to employ these techniques in MATLAB in the next 3 sessions. And then the rest of the semester will be for you to finish that problem set and probably any problem sets that Dean Jomar might have given you. But you can also spend that time to consult with me. So just schedule a consultation with me one of those days. So, but please tell me in advance so I can make the proper arrangements. If you want to do it face to face, it's also fine. If you want to do it online, just let me know. We can use the 5:30 to 7 time slot if you still need some consultations in the starting week after next. So that will be great. But again, please tell me probably at least a day in advance so that I can arrange my schedule accordingly. All right. So with that, I think we're all good. We can call it a day. So thank you guys for joining me today. Have a nice evening, and I'll see you again on Thursday. Bye,
Thank you,
everyone.
sir.
Thank you, sir.
Right.
Sir.
Thank you, sir.
All right. Bye, guys.